Today our discussion will be hydrogen peroxide chemical formula H2O2. It is an important chemical used in treatment of domestic and industrial effluents. Okay, so this chemical H2O2 or hydrogen peroxide is also used in green chemistry. Okay, green chemistry means environmental friendly. Okay, those are environmental friendly. So it is also used in green chemistry to control pollution. Now let's come to preparation. Okay, that is brief introduction. Now preparation. So how we are going to prepare H2O2 or hydrogen peroxide? Okay, the first method is by acidifying barium peroxide. Okay, so first what we are going to do is we will acidify this barium peroxide. So formula is BaO2 8H2O. Okay, acidified by sulfuric acid. So after acidifying, what we get is barium sulfate plus H2O2 hydrogen peroxide plus 8 molecule of water. Okay, so after acidifying barium peroxide, okay, this excess of water is removed by evaporation under reduced pressure. Okay, so after acidifying, we remove this water molecule, okay, by evaporation under reduced pressure. The next method is by electrolytic oxidation of acidified sulfate solution. Okay, in this case electrolysis will take place, and then finally, okay, we'll get the product. Okay, let's see. 2HSO4. Okay, so sulfate solution. Okay, this is sulfate solution H2HSO4, 2 moles of HSO4. Okay, so first what we are going to do is electrolysis. In this case high current density is given. Okay, so after electrolysis it will give HO3SOO SO3H. Okay, so this is peroxo disulfate. Okay, so why disulfate is here 2 sulfate is present. Okay, this sulfate, okay, sulfate HSO4. Okay, see here, this HSO4 we can write it OSO3H. okay, that means 4 oxygen present, 3 and 1, so 4. Okay, so in this case also S. Okay, 1S O4, 1S. Okay, 1H. Okay, so we simply rearrange, okay, and write it HO3SO SO3O. okay, so peroxo disulfate. So in peroxo, okay, you will find oxygen. Okay, so it is named as peroxo disulfate. Okay, so in peroxo you will find these 2 oxygen, so this is named as peroxo disulfate. So this on hydrolysis, okay, when we hydrolyze this, we get 2HSO4 minus plus 2H plus hydrogen peroxide. So finally we get this one. Okay, this method is also used for the laboratory preparation. Okay, I'm writing in short form, preparation of D2O2. D2O2 means deuterium. Okay, D means deuterium, O2, that means heavy peroxide. Okay, this D2 is heavy hydrogen. Sometimes we call it as heavy hydrogen, so heavy peroxide. So K2S2O8, okay, it is prepared by the reaction of K2S2O8 with G2O, okay, to give 2KdSO4 plus G2O2. So we get heavy peroxide, okay. So this might be asked in exam also, how you will prepare this heavy peroxide, okay. So this is also kind of important. Let's see the next method. Next is industrially by oxidation of two alkyl anthraquinols. Okay, so let's follow your textbook. Two alkyl anthraquinols. So this two anthraquinol will undergo oxidation, okay, in presence of air. H2O2 plus what you get is oxidized product. So this is given in your textbook, okay. You can follow this one also. I'm going to give another one also, the chemical formula of this one, okay. So anthraquinoline, 2-ethyl anthraquinoline, this is benzene ring, okay, benzene ring, C2H5. So this is 2 alkyl anthraquinone, presence of oxygen give hydrogen peroxide and oxidized product. So after oxidation the product will look like this, okay. C2H5, okay, this is C2H5. So if this is complicated for you, you can study this one, okay. So in this case you will get 1% H2O2, okay. 1% H2O2 is formed. However, you can extract, okay, H2O2 with water, okay, extract with water and concentrated. I'm writing in short form, concentrated to about 30%, okay, by distillation. So you can extract with water and then concentrate it to 30%, okay, by distillation, okay, under reduced pressure. I'm writing in short form again, pressure. So it can be again concentrated to or further concentrated to 85%, okay, by careful distillation. So the remaining, okay, can be frozen out, okay. Obtain pure H2O2, okay. Now we come to physical properties. I've already given here, okay, to save time. So in pure state, H2O2 is almost colorless liquid, okay. So you will see very pale blue, okay. It will be almost colorless, okay, or it can be very pale blue, okay. Now H2O2, okay, is miscible with water in all proportion and forms hydride as H2O2 H2O, okay. Hydride means water molecule will be present, okay, in a compound or chemical, okay. miscible means it can be dissolved. Okay, now it is poisonous. Okay, this H2O2 is poisonous. It has higher density than water. Okay, so it has higher density than water. Now structure, come to structure of H2O2. So structure of H2O2 is non-planar. Okay, but in short form structure. So what we are going to see is the gas phase and the solid phase. Okay, the structure of gas. Okay, H2O2 in gas phase and in solid phase. So the structure look like a open book. Okay, please avoid my bad drawing. So the bond angle here is 94.8 degree. Okay, and the dihedral, okay, dihedral angle is 111.5 degree. Okay, this is for gas phase. Okay, bond angle here 94.8, dihedral angle. Okay, hedral angle, I'm writing in short form, simply writing angle. Okay, in that way. So the bond length distance, okay, here is 95.0 picometer. Okay, this oxygen to hydrogen bond length. Okay, and from oxygen to oxygen the bond length is 147.5 picometer. Now let's see in solid phase. Okay, the structure in solid phase. So let's draw here. Okay, almost out of space. Now in this case the bond angle is 109.9 degree. Okay, and the dihedral angle is 90.2 degree. Okay, so for solid it is 90, and for gas 111.5. so the bond length here between hydrogen and oxygen is 98.8 picometer, and between oxygen 145.8 picometer. So this is non-planar. Okay, since OH the OH bond, they orient in different position. Okay, the orientation is in different position. Now chemical properties. It acts as both oxidizing and reducing agent. Okay, it can act as oxidizing or reducing agent in acid and alkaline medium. Alkaline means base or basic medium. Okay, let's see the first one, oxidizing action in acidic medium. Okay, so this reaction will take place in acidic medium. Okay, in this reaction oxidation will take place. Let's see, 2Fe 2 plus 2H plus hydrogen peroxide, Fe3 plus 2H2O. So in this case, okay, when you see proton, okay, that means acid is present. Okay, whenever there is a proton, okay, because acid donate proton. So in this case, iron is in +2 oxidation state. Okay, after oxidation it becomes +3. Okay, so from +2 to +3, that means iron is oxidized. Okay, here. Next is PbS plus 4H2O2 to give PbSO4, 4H2O. So in this case, PbS is oxidized to PbSO4. Okay, so in this case, from lower oxidation to it will form higher oxidation state. Okay, reducing action in acidic medium. So it can act as a reducing agent also. Dihydrogen, it can act as reducing agent. So MnO4 to MnO4 minus 6H plus 5H2O2 to give Mn2 plus 5 8H2O plus 5 oxygen. In this case, what is happening is MnO4, okay, or is oxidized to Mn. Okay, so here oxidation become less. Okay, in this case. Here Mn is in +7. Okay, and it after oxidation, the oxidation state change to 2 plus. Okay, so that means if the oxidation number decreases, that means reduction takes place. Okay, again we can see even without oxidation, okay, state, again we can see MnO4 reduced to Mn only. Okay, so it reduced to Mn2 plus or metal ion. Let's see another one. HOCl plus H2O2 to give H3O plus Cl minus plus O2. So in this case, what happens is HOCl gets reduced to Cl minus and oxygen. Okay, so it gets reduced to Cl minus and oxygen. Now let's talk about oxidizing action in basic medium. Okay, so this reaction will take place in basic medium. To Fe2 plus H2O2. So here iron is in +2 oxidation state. Now after oxidation it will be in +3 oxidation. Okay, and we get OH. Mn2 plus hydrogen peroxide. Oxidation takes place, so Mn4 plus, okay, to OH. So oxidation number increases. Okay, in oxidation. Now reducing action in basic medium. Let's see example. Iodine plus hydrogen peroxide plus 2OH minus. So I2 become just I. Okay, that means it gets reduced. Okay, 2HO plus O2. So from I2 to it becomes simply I. Okay, that means reduction has taken place. Now next example, MnO4 minus plus 3H2O2 to MnO2 plus 3O2 plus 2H2O plus 2OH. So from MnO4, okay, O4 means 4 means it will have higher oxidation, okay, and O2 means it will have lesser oxidation. So it get reduced from higher number to lesser number, okay. We are not calculating all those oxidation state here, and we are not yeah, please avoid those background noise and all. Here we are not doing the balancing and all, okay, as it will take much longer time if you discuss all the balancing and all. So you practice, okay, those balancing and all, chemical balance. Now storage of H2O2, okay. This H2O2 is reactive, okay, it is highly reactive, okay. Let's see. H2O2 decomposes, okay. Decomposes means it breaks, okay. Let's see, okay, as we go on we'll discuss. Slowly on exposure to light. On exposure to light also it decomposes, okay. So it is kept in a dark place, okay. This chemical hydrogen peroxide 2H2O2, it decomposes to water and oxygen, okay. So while keeping this hydrogen peroxide, you should avoid light, okay. It should be always stored in dark place. Okay, still more is coming. Presence of metal surfaces, okay, surfaces or traces of alkali, okay. So traces of alkali you will find in glass, okay, present in glass or glass, that's called glass container, okay. So in lab usually we use glass container, okay. So the presence of metal surface or traces of alkali will catalyze the above reaction, okay. I'm writing in short form. So in presence of metal surface, okay, or traces of alkali present in glass container, it will accelerate, or catalyze means it will accelerate this reaction, okay. That's why it is stored in wax line, okay. So inside, okay, there will be wax, okay. So in wax line or plastic vessel, it is stored in plastic vessel in dark, okay. That's why it is stored in wax line glass or plastic vessel. Urea is also added, okay. A stabilizer. So urea is also added to stabilize, okay, this reaction. So especially while keeping this chemical compound or chemical, what you need to do is it should be clean, okay. The environment should be clean, okay, free from dust or any dirt, okay. As in presence of dust, this okay, hydrogen peroxide becomes explosive, okay. So it might create explosive, okay, if you made mistake, okay. So it should be kept in a clean, dry and dark place, okay, to avoid decomposition of this chemical or explosive, okay, to avoid explosions also. Next is heavy water. So this is same for deuterium, okay, or heavy hydrogen, or we say heavy water. See, this is D2O. So chemical reaction is not given, okay, only the sentence is given in your textbook, okay. Heavy water, D2O. So it is prepared by exhaustive electrolysis. Okay, so it is prepared by electrolysis of water. Or as byproduct in some fertilizers. Fertilizer industries. Okay, so this D2O2 is also used in nuclear reactor. Okay, nuclear reactor as a moderator. It is also used for preparation of other deuterium compounds. Okay, let's see some example. CaC2 plus 2D2O. Okay, C2O2. Sorry, C2D2. Okay, this is D2 plus CaOD. So this is another deuterium compound. SO3 plus D2O, D2SO4. Okay, Al4C3 plus 12D2O, 3CD4 plus let's write down here AlOD3. So these are some of the reactions of heavy water. Now the last topic, it has been removed from your textbook, okay, by the board. Hydrogen SFO. This has been removed. Okay, so we can leave this topic.